This is the display screen on my comms test set. It's a Hewlett Packard 8924C test set, and we have a radio here. We're going to test the receiver of this radio. I'll just turn it on. You can't see the radio, and the brand of the radio is immaterial. The reason why we're doing this test is I'll explain at the end. The radio is on channel 69, Hancock Forest Management 69. We've got neg 116 dBm going into it. We've got a deviation of 2.4 kilohertz. You can't hear the radio tone at the moment because the CTCSS tone's turned off. I'm just going to turn that on and you hear the tone. There it is. And you should be able to hear the tone in the radio in the background. What we're going to do now, we're going to do a little experiment. We're going to leave the level into the radio exactly the same, neg 116 dBm. And leave the CTCSS deviation alone. But we're going to come over here to the modulation deviation here. It's currently 2.4 kilohertz. I'm going to wind this up. Now I expect this deviation to cut out. Here it is. .3 kilohertz is gone completely. By the time you get up to 4.8 kilohertz, it's all over. Way back down here, you go 2.7, you got your tone back again. And as soon as you get up to here, the radio starts to become intermittent. By the time you get above 4 kilohertz, it's all over. Now, there are only two rules in my trade. First rule is get a license. The second rule is comply with the terms and conditions of the license. Now, since the 10th of November 2015, I think it is, every radio license in New Zealand has been narrowband. All the old wideband licenses were terminated on that date, 10th of November 2015. However, we've got a competence problem in this industry of mine. Only last week I was asked to go and reprogram the radio channels in a fuel tanker. To my distress, I discovered that more than half of the channels in this fuel tanker, which came out of the Auckland district by the way, were all programmed wideband. Now, there's a serious risk here, and I've just demonstrated the serious risk. If you've got a narrowband radio, and it's correctly programmed with narrowband channels, as this one is here that we're testing, and coming up the road in the opposite direction is a wideband radio. When that wideband radio transmits, the narrowband radio can't hear it. Now what's actually happening, I believe, here is that the wideband signal goes through the radio and gets probably to one of the IF filters, and then gets badly chopped about and clipped by the IF filter, and then that badly clipped signal is not able to be correctly discriminated, and so the radio actually shuts the audio off. So what this does is it actually creates one audio only in one direction. Now obviously if you've got communications on a road where roads are fairly narrow and people begin to rely on their radios, you've got a health and safety risk here. You've got one-way audio or communications only in one direction. Now if this is the primary cause of an accident, and that accident results in somebody losing their life, the reparations alone will probably exceed $50,000. So I hope you've got a spare 50 grand. Either that, or you ensure that in this band, the E band, you cease programming wideband channels, and probably more importantly, if you are asked to program something, what you should be doing is going onto the Radio Spectrum Management website and looking carefully at the license to determine whether it is a wideband channel or a narrowband channel, and just to correctly program other stuff as well, including CTCSS tones. which might actually be a subject of another video. But just beware, you shouldn't be programming wideband, and indeed if you've got old wideband radios out there, they should have long gone as well. Other than that, I suggest you start saving, because you might need a spare 50 grand.